Hello, Geometry World. This is the video of example 3 for Geometry Topic 2, Lesson 2. We're going to first start with the converse of the same side interior angles postulate. If two lines in a transversal form same side interior angles that are supplementary, then the lines have to be parallel. Notice they're not supplementary, right? They add up to 200. Those lines don't even look close to being parallel. But once you get to, well, let me move this one instead. Once we get to that they are supplementary, I still got to go a little bit farther. 140, 44, 44, because 44 and 136 add up to 180. Once these add up to 180, those lines have to be parallel. That's the same side interior angles. That's the converse of the same side interior angles postulate. And similarly, we have the converse of the alternate exterior angles theorem. The alternate exterior angle, okay, if we have two lines cut by a transversal and the alternate exterior angles are congruent, then the lines have to be parallel. So they're not parallel here, but once I get that the lines end up, the angles are the same, still not parallel, but once I get that the angles are the same, then I know the lines are parallel. Okay, it's just the converse of what we've already covered in an earlier section. Moving on, how do they want us to apply this? The edges of a new sidewalk, this is the sidewalk, okay? The edges of a new sidewalk must be parallel. This edge here, outside edge, inside edge. I don't know if they're really inside or outside, but the left side edge and the right side edge need to be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edge of the sidewalk are parallel? How can he do that? Well, he's going to come right in here, and you can see how we have some angle 1. Well, let me click solution so they can explain it. First measures the angles of the corners of the sidewalk. So forget about that I had angle 1 there. He measures that this grass to the road is 53, and here in the road, from the road, is 53. Using one line, right? This is a straight line, and those are alternate exterior angles. And if they end up being the same, like they do right here, 53 and 53, the two edges of the sidewalk must be parallel. Okay, and that's kind of what they said right there. Since the two 53 degree angles are congruent, he can apply that converse theorem. Moving on. Now they're asking you, what's the measure of angle 1? What should the measure of angle 2 be in order to guarantee that the sidewalk is parallel to the main street? To make sure that this sidewalk is parallel to the main street, what does angle 2 have to be? Okay, click pause, figure that out, and then come back. All right, I can see that this is a straight line. So 53 and 1 are supplementary. They're a linear pair, so they add up to 180. So 180 minus 53 is 127. And then I see angle 1 and angle 2 are same side interior. If these are parallel, then these would have to add up to 180 in order to make those two parallel. And if this is 127, then 2 must be 53. Now you might have said, well, this is 53, so this must be 53. And that would be true. That would be from the converse of the alternate interior angles theorem. I used the converse to the same side interior angle theorem. Let's see what they used. They used same side interior angles, but you could have gone with 53, 2 must be 53 in order for the sidewalk to be parallel to the main street. All right, that's it for this section. Let's see what we have for problems. You can do problems 14, 15, 8, 9, and 21. That's it for this video. Have a great day.